First of all, actually, I'm delighted to be here and see what is happening. What we started as a proof of concept is in the commercial process. As a person, I'm really eager to be part of this whole process. I have been working with RMR processors and others who were involved in the designing. This is one of the reasons actually the success is we all are working together. I have been involved in so many other projects. Sometimes we don't work the similar way. Somebody develops something and somebody else take over, do something else, end up with a disaster. So here I can see a very good success. And at the same time, you might be thinking, by profession I'm a food scientist, so what I'm doing with chicken feed. It is totally different. But in real world, the difference between food and feed is not much. Only difference is way we produce these or the hygienic conditions we are following. Otherwise, practically it is the same thing. So we are animals actually. So this is the process we were involved in at the very beginning. So we wanted to convert food waste, which is not valuable product, into a valuable chicken feed. Norm gave us a very good introduction at the beginning, so I'm not going to go through the details of why it is important or how it is important. So basically we thought that we want to get range of materials with potentially has a different nutritional profile. So these are the ones we selected, 9 different sources. And some of the cases like fruits and vegetables, we selected from more than one source because that is one of the common sources, especially if you are talking about big city like Sydney, Melbourne or other places. Just to give you a snapshot of how it looks like. None of them looks good, looks terrible. So process wise, you saw what is real process is, but we did the same thing in a very small laboratory scale. Practically the same process, but of course we tried so many different drying techniques, so many different heating techniques and various other things before we come up with this final steaming. So we used the normal cooking, pressure cooking and steaming and various other techniques to find out actually what is best. So what I'm giving today here just a snapshot. So this is what is happening with the different streams. Dry matter content or the feed material and the amount water varies depending on what the product is. If you look at the something like fruits and vegetable, for example, it has a very high level of moisture or the water, but very low level of dry matter. And some other streams actually has about 40% dry matter compared to the water. So if we organize the samples, the protein content range from about 10% to almost 40%. So in other words, by blending different streams or different sources, we can produce feed starting from low level of protein about 10% to almost about 40%. Most of the feed protein content what we need about 15 to 20%. So in that case we can comfortably say that we can meet the protein requirement by using these different streams. Fat content is a very important thing. In most of the human food, our recommendation is to reduce the fat content as much as possible. But when you are talking about feed, that is not the case. We need a lot of fat in the feed industry because we want them to grow fast and produce more products. So in that case, various food products or the feed product depend on the fat content. So here we have a very big range, somewhere around 5% to almost 30% fat content. So that is a very good sign. So we can blend different ingredients or different sources to match the fat content and the protein content we want in any product. I know that Norm is focusing on the chicken feed, but as a scientist, we can make any feed, whether it's a chicken, poultry, or fat, fish, doesn't matter. We can match the nutrient content what we need. Only thing is, in some cases, we may have to add some vitamins and mineral. But that is a common practice in the industry. They add vitamin and mineral in a chemical forms, and we can follow the same process here. So in our pilot trial or the proof of concept, these are the 4 products we mixed together. And by doing that, we were able to produce the chicken feed, which is very similar to the commercial requirement. And we did not go through the details of getting the vitamin and mineral content balance, but that is actually a minor issue. Main thing is the protein and fat content. So in other words, actually, we can get various sources and produce the product we want. So it is a successful process. That is why we see that what is happening today. And it is a commercially viable, definitely yes. And good part is we convert waste into a zero waste product. So in other words, we get the waste, one side we get the feed, and what is coming as a liquid, we use as a liquid fertilizer. So in that particular case, it does not produce any waste at all. So directly we have a commercial benefit, but indirectly we have a lot more benefit because we are reducing the environmental pollution, or what we call greenhouse gas emission. We reduce significantly. By that time, we are reducing the global warming. And that is a very short description of what we did initially.